And camera.
Camera. Okay. Where you will be. Yeah. Okay.
Yeah.
Okay. And we will start.
Good morning. Can you hear us?
Yes.
Okay. Okay. And can you see the presentation?
So there's 3 people online.
Okay. So.
Not yet.
Not
you
yet.
have to focus. Yeah, but you have
Already
to start.
shared the.
Yeah, activated, but
no.
Can you start the presentation? Yeah, and start the presentation. Step 5. No, that's the much.
No. Alright.
Okay, just check that they can.
Can you hear right now? Okay. Now it's okay. Good.
Okay.
He
will say yes.
Yes, because I'm not sure if we're able to manage that.
How to start the presentation again? The F.
Yeah.
Someone wrote something.
What?
During the development time, we check and it's working. Sure. Okay. We'll check this. Okay. It's good. Oh, yeah.
Okay. Good. I'll go in my office and try to see whether I can also be a student. Okay? Okay? See you later. We are ready to start. Thank you all for coming. And Mrs. Shifi will present Evie today. And you will have a very good understanding at the end of the course how you can use one such state-of-the-art software in order to do an evacuation analysis.
Thank you, Alejandro. So, good morning, everyone. Sorry for the late start. So my name is Yasmin Hifi. I'm a research project manager at Brooks Bell. Been working there for 3 years, and before that, I was a research assistant here. Been working with Evie for a number of years now. So briefly to tell you about Brooks Bell, we are a consultancy, marine consultancy company. We do surveying, loss adjustment, expert evidence, and things like that. So if anyone is interested in finding out a bit more about what we do, our website is brooksbell.com, and I do have some material here. If anyone wants to have a look at the break, they can do, and for people who are attending online, you can go on our website and have more information. Before we start, are you all here students at first time? Yeah, right, okay. Does any one of you have a bit of experience with evacuation analysis apart from the course that you know nothing about evacuation analysis? So the historical background a bit, just to set the scene up. Again, the problem in the maritime is it is a reacting field. So they wait for an accident to happen, then they start reacting. So the guidelines for evacuation analysis, unfortunately, came after an accident, which was the Scandinavian Star. It was a fire on board that ship. After that, they decided that it would be quite important to have a way to assess how you could evacuate people safely from a ship. So that's a bit how the guideline for evacuation came into play. I don't know how much you covered yesterday regarding the IMO guidelines. I will talk mainly about the part that is relevant to advanced evacuation analysis, which is the one that we do with computers. So I think you've seen that yesterday. So you have two parts. You can assess manually and design, but you can also do it with the computers, and that's the second part of the guidelines that we are going to have a look at. So today the presentation, I'll go through the IMO guidelines because that's important to be able to understand the evacuation. I'll talk about the theoretical background of EVI, a bit how we use EVI for what it is used in general. We also have the capability of including data about fire and flooding. So if there is a casualty about on board dealing with fire, we can right. And the second part will be the actual hands-on. There are two parts of the software, the editor and then the evacuation simulation tool. Has any one of you requested to install that on your computer before, or no? So that would be the first time you see the software today. I'm just asking so I can see how much detail we need to go and if you had already a play with it or not. So the guideline, the IMO guideline is the MSE 1238. Before that, there was the 1033. This has been, the first one were just interim guidelines. This one is now the one we use for the evacuation. So why do we use that? Why do we do that? It's basically to assess the design. We are not modeling an emergency situation, and that is very important to understand that. A real emergency situation means you have to deal with other aspects, other human factor aspects. Here we just have a design and we assess it in terms of time. Do we have enough time to safely put everyone in the muster station and then evacuate through lifeboat or life raft? Oops. So if we have a design, what we want to do is to see where do we have congestion. So imagine you have a layout. This is a restaurant, for example. You have those two exits here, and you want to know if the way you have designed your room, the width of your door, the position of the door, is that okay for everyone to evacuate safely if there was an emergency? The same with the corridors, same with stairs. So when you do an evacuation analysis, you can see people moving around, and then you can highlight areas where you could potentially have problems if people are stuck in some places. Then once you have done that, you can come back to the designer and say, well, look, here there are problems. We have highlighted those issues. And that's their duty to make sure that this has been cleared, and they have to adjust their design so they would address this problem. Any questions so far? Please do not hesitate to interrupt at any moment. If you have a question or anything, just let me know. So as you might have seen yesterday, the IMO guidelines have two parts. So we have the first one, which is Annex 1, which is the simplified analysis. This is based more on hydraulic systems. So you see everyone a bit like a liquid going through pipes, and that's how you assess your design. But for the one we are dealing with today is the Annex 2, which is the advanced one, and that one uses computer. So that's more elaborate. So, well, clearly it's computer-based, and in that case, what we lack in the hydraulic system is that everyone is together. So you don't have people, you can't see people as autonomous agents. Whereas is an individual, and you can interact with those. I don't know if that was something you covered with Veloz yesterday. Yes, so you have a bit of an idea. Have you seen other software? Did they talk to you about any other evacuation software that are available on the market? Yes? Yes. ANEAS? Yeah. DTT? One FDS evac? No? the one from VPT, there's Odigo, France. Well, there's few of them around, but the idea is the same. You have every agent as an autonomous entity. So you also need to have your layout. So the ship needs to be modeled in quite in a detailed way, so you can assess where you have problems. And your agent has to interact with the layout. So you can't have an agent crossing walls, or they have to respect the boundaries, that they have to follow the routes and the stairs and corridors and whatever they are there. So right. The IMO guidelines also have some assumptions. So when you do a simulation, there are a few things that you need to assume. You can't take everything into account. There would be a lot of factors to consider. So what we assume when we do the evacuation analysis is that everyone will use the main escape route. So you're not having people going around the ship trying to find ways, although you can do that for other purposes, but that's not the point. We also assume that you have everything available, so all the routes and everything is available. Once you have done that, we also add a safety factor, because there are things we cannot model, for example. So that's what we call model omissions, so things that you cannot model. You also assume that the crew are immediately at their emergency stations, which is not the case in a real emergency. When you have a signal, an announcement through the PA that there is a problem, crew will assemble at their specific points. So if there's a fire, for example, firefighter team will go to special areas where they will collect the materials to fight fire, etc. Then they will go try to contain the fire, and if not, then we have the general alarm. But so that's the kind of things that we assume are there, and we have this safety factor to take into account these things. One important thing also is that the fire and motion are not taken into account. So the effect of smoke, shoot, toxic gas, etc., is not taken into account into the simulation. Although when you couple it with fire data, then you have a different level of information that I'll talk about later. The same with ship motion. We also assume that there is no group behavior. So, example, if you are on board with friends of yours, you won't tend to go on your own. You will try to look for people who are with you, so you all go together to the master station. The same with families. But this is not modeled. So we assume that there's no group behavior, and that's why we use the safety factor. Now, to be able to do an evacuation analysis, we need some parameters. And in your opinion, what this could be? Do you have any idea what we would need to do, or what we would need to have as information to be able to do an evacuation analysis? Yeah.
Depending on, like you said in your presentation, depending on the age of the passenger, they have different speeds that they move, and also perhaps what time of the day it is, because at night, for example, in a cruise ship, most people sleep, while in the day they are more active.
That's exactly that. Yes, that's the two main parameters are your walking speed and your reaction time. That is what drives the whole simulation. And then you have all the interaction between agents and things like that, but that's the main important parameters. So that is why this is defined in the IMO guidelines. So they tell you what data you need to use for the speed, what data you need to use as the response time, and then we'll go through the other element afterwards. So for your population, the data here comes mainly from cruise and passenger population. So that's roughly how it is distributed. So you have 10% of older people. So some Imper 1 and Imper 2 is their mobility. So they would assume that some of them are fitter or walk faster than others. Then you have the younger group, and the middle group, and that's per gender. For the crew, we just assume that they are fit, trained, so they have one specific walking. It's not like the passengers. And for the crew, we just assume that we have 50-50 in the in the crew, but that doesn't have a big impact because they are walking at the same speed and they react at the same. So for the reaction time, this is based on again data. Most of it comes from the building industry. So the distribution is assumed to be a truncated log normal distribution, and you have two different distributions, one for the day and one for the night. So during the day, as you said, people are active. They are around places, on the sun deck or at the restaurants or whatever. So they would react quicker if there was an emergency. The night case, people are fast asleep sometimes, so that will take them longer to react. What we also take into account in the response time is any action that people will do before starting to evacuate. So any pre-evacuation activity is also accounted in the response time. So let's say, for example, they tell you, the general alarm, you have to go to the muster station. Some people will try to gather things, although you're not supposed to, but some people will want maybe to take some belongings, some others will try to look for other people, some will have some reactions.
Yeah. Of our students.
Yes, sure.
Okay. Sorry about that.
No.
Okay. There's a problem with the software.
Oh.
Yes.
Are they not online?
Yeah. No presentation available. No. And clicks automatically. Don't know why. Can you see? Can you see right now? Okay. Sorry about that. It disconnects every 2 minutes.
Oh, okay. So should I keep an eye on?
I still can't see. Disappeared again. Here it seems that it's okay. And share screen icon. Yeah. I spoke with Angel about that. Sorry. Is this okay right now? No. Just a moment. Now? Okay. Yeah, I have to check
were they able
frequently.
To hear?
You are able to hear? Yeah, I'm trying to find okay. So I'll check my messages every 2 minutes. Let's see. No, yes, because I disconnect the presentation right now. That's why. Suppose that you can see right now. Okay. Okay. So can we?
Why does it say has connected? Is it a problem from their side or?
No, it's a software problem. Now
Okay.
presentation now. Yeah, it disconnects automatically. Don't know why. We have to connect it every 2 minutes. It's very bad.
What if you start again? Do you think that will solve the problem?
And only webcam.
Are there any other parameters you can configure?
No. I can see here 4 users, the moderator and 2, Stefano and Andrea and Unige. Stefano and Andrea are with Unige or not? Because if we are with Unige, we can do it. Okay, can we do it with Skype then? To be sure. Okay, we'll do it with Skype. We're still in Spontanea, but we'll use Skype. So in 5 minutes, we'll give me an account in Skype. Stefan, okay. I call you Stefan on Skype and we'll share our screen. Okay.